Welcome to Founder Friday. It is our April edition, and we are so excited to have you back. Last Founder Friday, there was a question posed about plant health and pest control, organic pest control, specifically in the garden, but just in farming in general. And so it was such a big question to try to unpack, and we were kind of going long last time, so we wanted to save that for this Founder Friday. So today, David is going to be talking to all of us about organic pest control, and he is going to be going over the plant health pyramid, which is here on the board behind me. If you have questions about this topic during our live, please feel free to put it in the comments, and we will feed those questions to David so that he can answer those for you. We'll be watching, so please feel free to comment about this topic, and we will do our best to get to everyone and have those questions. Yeah, and about gardening in general. That's okay. It doesn't just have to be about pest control, as David just reminded me. It can be about gardening in general as well, because this is the season. This is the time of the year. So without further ado, I'm going to pass the floor to David.
Well, hello everybody. Hey, it's April. It's a wonderful time to be planting our gardens. Can't wait to get in the dirt. We've had a little bit of a cold little bit here, so haven't really got very much in yet because it's been a little chilly on our side. But hey, it's getting there. It's right on us. And I know most parts of the country are good to plant gardens now. So anyway, the question was asked last time, how do you do organic insect control? And that is a little bit longer answer, because the number one thing for insect control in an organic garden is to have a healthy plant. So it's not about necessarily doing some kind of chemical or some kind of, there are things you can do, and I'll hit some of those a little bit later. But first and foremost, number one is, if you have a healthy plant, bugs don't eat it. And so very quickly, you say, how could that be? A bug probably likes things just the same as, a healthy plant makes a healthy bug. No, not correct. A healthy bug is made by an unhealthy plant. And a healthy animal or a human is made by a healthy plant. And there's a difference. And I think nature was created that way so that the unhealthy plants get eaten up by bugs or diseased out, so that they don't reproduce and create a weaker species. So the healthier the plant, the less the insects attack it. So now behind me here, I had put on the board what I call the plant health pyramid. And so every plant is, well, number one, so the base bottom of the plant health pyramid is what we call the sugars, or the saccharide, or we're looking at the standard photosynthesis of a plant. That's what plants do. They turn sunlight and water into sugars. They're the only thing on Earth that can do that. Plants turn sunlight into sugar. Sugar is the energy for all life on Earth, whether it's plant, animal, everything. And I'm not talking about sugar in the sense of that white stuff that people tend to have too much on. This is the basic building blocks of energy on Earth is sugars. So in a healthy plant, where's your marker? In a healthy plant, you have a plant. Oh, this that one doesn't work, but It has, there's basically 4 different places that the plant puts its energy. So if you, I'm going to do this very simple here. And so, just for a diagram's purpose, there are 3 major parts to the plant. So you have the structure of the plant, so the trunk, the branches, and so that's your structure. Then you have your fruit, so that's the reproductive part of the plant. That goes to the next generation. And then you have the roots. The roots are also structure, but the roots are what brings in the nutrients, and it anchors the plant both. So, but the very important function of the roots is that they bring in the nutrients. Now there's a 4th component here of a plant, and that is the supporting microbes that live in the soil next to the roots. And those microbes are what actually gives the it changes the soil, the minerals and the nutrients that are in the soil, to a usable form so the plant can use it to create the fruit and the structure. And obviously when we're eating the fruit, we want to have the minerals that are appropriately chelated by the bacteria that's in the soil. So when a plant makes sugar, in the case of a healthy plant, it allocates about 25% of its sugar to creating its structure. The stems, the leaves, all of that. About 25% to reproduction, creating the fruit and the seed. About 25% to creating the structure of the roots, and to have the roots go out and gain new nutrients. And then about 25%, and this is the part that's often forgotten about in standard plant biology, is about 25% of that sugar is exuded out of the roots to feed those microbes that live next to the roots on the plant. Now, microbes can't create sugar either. Only plants can do that. Microbes have to have energy to break down minerals and volcanic ash or silt or other plant debris or whatever the soil is made of and what goes into the soil, probably all of the above. They need that to break that down. So to have a healthy plant, to have healthy nutrients in the plant, that plant has to have feed those microbes to give them plenty of energy to break down, and it becomes a very important symbiotic relationship between the plant and the microbes that live in the soil. That's the foundation for a healthy plant. So number one, when you, in conventional agriculture, many times, they're actually, because they're pushing, and we'll talk about that more in the next step here with the protein, but they're pushing the growth with anhydrous ammonia or something along those lines. The plant grows too fast to be able to make enough sugar through its photosynthetic action to do all the functions that are needed. And so the first thing that drops off is the feeding of the microbes, because the plant doesn't absolutely have to have that to live. It thinks it's an emergency. There's a temporary emergency. It won't feed the microbes. The microbes die back, and actually when the microbes die back, their bodies create fertilizer, and it makes the plant grow even a little bit more and more quickly, but the soil begins to deteriorate very rapidly. And then the next generation of plants will be less and less healthy. So that in a healthy plant, it has a diversity of sugars. I think they're called polysaccharides, and that it's not all one thing. But the first sugar that is produced in a plant is fructose. And the fructose, so in many modern plants that are done under conventional agriculture, you have a monosaccharide, typically fructose. Fructose goes, so when a human eats the plant, fructose is not the right kind of sugar for us. It gives us a spike in blood sugar, it crashes very quickly, and it digests almost instantly. We have no long range, so it actually helps to build fat instead of long-term energy. And we can talk about diabetes and other things that come into play here. In the case of an insect, it's just the other way. An insect's digestive system is not designed to digest complex sugars. It only digests simple sugars, specifically fructose. And that's not all insects, but that is all the, shall we say, sap-sucking insects. Your insects like aphids and whiteflies and things like that. So if you can get the sugar in balance and get a polysaccharide, those are just gone magically. They don't even see that plant as food. Plant's not food. They might go, and you can stress the plant. And, I've done this experimentally. So you go in and we have a row of plants, and a nice row all planted at the same time. And I've gone in and chopped some roots off and seriously stressed like a plant on the end, or failed to water it. And you'll see all the plants in the line don't have an insect on them. That one that you stress will just be covered in aphids. And it happens almost every time if you do that. If you run that experiment, it's totally repeatable. There's those insects love that stressed plant because it's making simple sugars, and that's the primary reason. Okay, so then as we move up the pyramid here, the next one are proteins. So the building blocks of life. Remember, sugar is energy. Protein is your building blocks. So building blocks, the similar things happen. So the building blocks need to be done through a complex amino acid. And when you one of the things, and I've explained this quite a few times when we're talking about wheat, and that's a really good example of the difference in protein here. But the same thing applies for plant health and insect. So when you have wheat and you put on anhydrous ammonia or some kind of an artificial growth stimulator, the wheat grows bigger and faster than what the soil is actually supporting it with. And I'm not saying under organic agriculture you get less yield. It just has to be in balance. You have to have enough microbes. If you have enough microbes in the soil, you can get way better yields than any conventional guy could ever get. But you have to have a balance of microbes against the building blocks of. Now, nitrogen in its true form is also an amino acid. So when you're faking nitrogen through anhydrous ammonia or something, you're creating a non-existent amino acid profile. So it's the plant thinks it has the amino acids that it needs, the protein building blocks, and it doesn't. And so it begins to build a very out of balance amino acid profile. In the case of wheat, the very first amino acid that the wheat begins to build is L-glutamine. So you get way more gluten, what's commonly known as gluten, which is, again, it's an amino acid, than wheat would naturally have. Wheat has some L-glutamine, but it should be in balance with the other amino acids. And in wheat, in healthy organic wheat, you have about 12 amino acids out of the 23, 24 that are known to be needed for human health. So the similar issues with amino acids as far as plant health goes. If your sugars are healthy, if you have a strong building block in the soil for the plant to make protein, so you have a balanced amino acid protein, and hey, all protein is going to it's all originally going to come from the soil as well. If you're getting protein from meat, that protein, the cow didn't eat meat, the cow got it from grass. And the grass got the amino acid profile from the soil. And very similarly, out of balance amino acids, now you have another layer of insects. There are other insects that like simple amino acids. Now you're into things like potato bugs, for instance. That's a good example of that next level. They're a chewer. They eat the plant, but they would like, or Colorado potato beetle, I guess, is the name of that one. But there's similar leaf-eating insects like that if your amino acids, if your protein is in balance, again, their digestive system is set up for simple proteins. They're a bigger bug, they need a lot of protein to build, but they need simple proteins. So if your amino acids, and I have actually done that exact same experiment similarly with potatoes specifically, and there's a bunch of other insects as well that fall into this category. But with potatoes, you have a whole patch of potatoes. There's not a Colorado potato beetle in sight. There is nothing. They didn't lay one egg on them. I mean, there may be an occasional beetle, but they don't lay any eggs. And of course, it's the larvae that really destroy the plant. And you go down to the edge where that was like not watered quite enough or something like that. Well, they're just stripped. They eat the whole plant. And it works. It works every time. So your protein profile takes care of that. And this is, and one of the keys with protein, healthy plants and protein, is your nitrogen potassium ratios. Getting your ratio right in the soil is key for the plant to be able to produce that. And remember, artificial nitrogen, the first thing that does is get that out of balance. And throws extra growth, but not very healthy plants. Now, 90% of the insects are taken care of with those two. So that's why I wanted to focus mostly on those two. Now when you talk about fats or lipids, actually in plant health they're called lipids. But the fat, again, it's about the balance of the different kinds of lipids. And for optimum health, we need a complex variety of fats. We talk about the different omegas, omega-3, omega-6, and so on. Really, and they say, get lots of omega-3, flax oil or, borage oil or whatever. Well, and that's all great because those are higher in those particular lipids. But the idea is that if we can have a balance of our fats, and typically the fats follow your bottom two. There's not as much of a specific trick to creating. So if you have your sugars and your amino acids in balance, if your microbes are creating the nutrients for your plant, your fats begin to follow. And now you're getting into, with fats, you're getting into a little bit more complex insects. So you're talking like, for instance, the cabbage butterfly, those kinds of insects that have a portion of their life cycle in a plant. And if your fats are off, even if you have pretty good balance on your sugars, those insects don't go away until you get up here with your lipid balance. And really, balancing these two are key to lipid balance, because you're dealing with the microbes that are in the soil and the health of those microbes. And then the peak of the pyramid is plants actually have a natural defense, and it's called essential oils. So I don't know if any of you have ever used essential oils in your, yourself for medicinal purposes, but if you have, there are particular characteristics of essential oil. So if essential oil is extracted out of a plant, and some plants have more than others, so let's say, peppermint's one that's very common to extract the essential oils out of. I mean, it makes great flavoring, it's used in medicine, it's used to calm an upset stomach, various things that the essential oil of peppermint will do for a human. Now, almost every plant has essential oils. We just don't necessarily extract them from all plants. But the essential oils become like an immune system to insects. So on top of all of these, being there, the essential oil actually puts out an aroma. And I've heard it actually described, and it's not exactly the same, but this is kind of a good description. When you have essential oils, the essential oils in a plant, they actually put off a frequency, like a little radio wave. They're putting off a frequency in that plant. And if the essential oils are in sufficient quantity and healthy in the plant, it puts off a frequency that an insect actually reads that frequency and it says, I'm not food. I'm a parent plant. If the plant is sickly, especially down here, those essential oils actually send off a frequency that says, come eat me up. I'm food. And, anyone who's into essential oils realizes that there's a certain frequency in essential oils. It's not exactly like a radio wave, but that may be the best way to describe it. That makes it somewhat simple. So if your plant health is strong on these, your plant begins to produce its own essential oil, which is basically its own immune system telling the insects, don't eat me. I'm good. I'm a parent plant. Okay. So I know that was probably a whole bunch real quick about plant health. So that is our key to plant health success. Now I can give you a few little hacks and shortcuts. I've had people, what if you can't make that happen? I just moved in, but I really would like to eat. I don't really want to feed all my plants to the bugs. What can I do? Okay, one key is essential oils. You can get essential oils from other plants that were healthy, and you can use those to discourage other insects. Thyme oil is a really powerful essential oil for that, as is neem oil. So those are probably two key essential oils that you can use from other plants. And so basically what you're doing is you're shortcutting or you're short-circuiting those radio frequency waves. So you're saying, hey, I'm going to put some essential oils on my plant that was from another plant that said don't eat me. So you're getting that plant to send that signal out because you artificially put that frequency on that plant. So that's one little hack that you can do that is usually quite effective. Some other keys, and I do this as a gardener anyway. But there are certain insects in the soil that are somewhat, for instance, the cutworm, the carrot maggot, I believe it's called. Some of those, and some diseases as well. White rot is another instance, which is only affects alums. And obviously, carrot only affects things in the carrot family. So having a long-range rotation of your crops in your garden, anything that's not a perennial, rotate your crops. Don't put it in exactly the same spot. If you planted carrots over here last year, plant them over here this year, and plant them over here the next year. Wait 3 or 4 years before you plant them again in exactly the same spot. Now, it's not because you can't plant them in the same spot over and over, but there's two things that happen. One is the same crop depletes the same nutrients in the soil. So by allowing it to rebuild for a couple years before you're going to take the nutrients that carrots need again, makes it easier for the microbes to keep up with these, making a healthy environment for the plant to grow in. So that's a little tip, maybe more of a tip, but it does really help with especially a lot of the soil-borne diseases and insects that you'll find that actually live in the soil. And there are, the healthier the microbe population, the faster that those will get out of the soil. Even if you do get some soil-borne insects, there's the bacteria in the soil. There's soil bacteria, and then there's protozoa, and there's nematodes. Now, nematodes are a big enough soil-borne microbe that they will actually eat most of the egg and larvae of most of the plant damaging insects. So if you can get a high nematode population, it actually helps. But there are more than one kind of nematodes. You do want healthy ones. There are some that actually cause problems, but with healthy soil, it will increase automatically the healthy nematode population. And nematodes are really key for a lot of, even some of the insects that you would never think about. For instance, walnut huskworm is a good example of that. Walnut huskworm, your walnut tree may be 50 feet tall, and you get a little black, the husk gets a worm in it, and it turns black, and it doesn't separate from your walnut properly. If it happens when the walnut's young enough, it doesn't, really doesn't even mature the nut, because the husk is what actually gives the nut its nutrients. Walnuts are extra lot of healthy fat. It's one of your key fat producing nuts for good health. And so there's a lot of nutrients that go into a walnut. So those little insects get in that. But the thing is, they winter in the ground because those fall under the ground, then they lay their eggs, they winter in the ground, and the nematodes are absolutely key to taking care of walnut huskworm. So, I mean, it's kind of a cool symbiotic relationship between, and then of course nematodes also feed on soil bacteria. So the microbes in the soil feed, well, you have basically, it's a whole thing in there. It's like so the bacteria, those reproduce usually asexually, they divide, and then you have, your protozoa, and those often feed on the weaker bacteria, and then the nematodes often feed on the weaker protozoa. It's part of, just kind of like the balance of nature amongst mammals. The same thing happens in the soil. So anyway, those are a few of the hacks that you can do just to get some of the bigger insects are some of the harder ones to deal with. For instance, those big old hunkin' tomato worms. Those are a little harder. So, having the kids pick them off just is a hack that you can do. They do. The essential oil piece does do the trick. But, their tomatoes grow pretty fast, so that fades out pretty quickly. So there are some, you can do that kind of thing, just pick them off. But anyway, that is my take and experience on fighting insects absolutely and utterly organically. Now there is one other thing that you can do, but this is a little bit more complex and would actually maybe be more for a farm. But there are actual bacteria that will eat soft-bodied insects. So there are bacteria that you can spray on, but they're fairly hard to get. Often they're referred to as EM in the general market, but those, if you're a farmer, I would say look into that. If you're a gardener, probably not so much. One other quick hack, if diatomaceous earth is a so what diatomaceous earth is, it's basically little microscopic pieces of seashell, but it breaks up more like little glass crystals. So microscopically it is sharp. Not microscopically it is not sharp. So to the human skin, or even the human digestive system, there's nothing there. It just passes through on the mucous membrane. To an insect, they don't have a mucous membrane. So if the diatomaceous earth gets onto their bodies, even the soft portion of the body, it actually punctures a little hole in the insect, and the insect cannot replenish its liquids fast enough to survive, so it will eventually dehydrate and die. And that's a very physical thing. It works really well in grain storage for insects that destroy grain. If you're going to store it, put a little diatomaceous earth right in the top, around the edges, anywhere that insects might be getting in or creating activity. But the insects do have to move. Diatomaceous doesn't work the greatest on things like aphids unless you mix it with something like soap. So it needs to have some way of making that insect, the insect's just sitting there sucking like a tick. Diatomaceous doesn't do much. Any insects that's moving gets in there and then it starts puncturing them. works pretty good.
So there was a question about the diatomaceous earth, which is, what's the best way to use it? Sprinkle it in the soil, spray it? What's the best way to?
Depends what you're going. Diatomaceous earth is physical, so it has to come in physical contact with your with the insect. So if you're going after a soil-borne insect, you can put it in the soil, but it does amalgamate into the soil pretty readily, and so it's not very effective unless the insects like cutworm that might be coming up. You can sprinkle it a little bit right around the stem of your plant, so when it comes up to try to cut your stem, gets into it. But the very most effective way is to dust it on if you have the ability to dust it on. But you can also mix it in water and spray it on. It still works pretty well that way. If you have an ionizer and can put a negative charge on it, plants are usually positively charged. So if you can put through an ionizer, you put a negative charge on it. And this is in commercial agriculture. If we ever use diatomaceous, this is what we would do, is you would dust it on through a negative ionizer. And that helps it to spread around all parts of the plant. So it doesn't just dust onto the tops of the leaves or into the little corners and stuff. You get it on the bottom of the leaf and around the edges and so on. But the more of the plant you can cover, the most physically, the more effective it is. But it's a physical thing. It has to come into contact physically, not like essential oils that sends out a radio wave. This is physical. All right.
So that was all the questions. Anything else that you wanted to add? I think everybody's just intuitively listening.
All right. Well, thank you.
We want to thank you, David, for sharing. This is so interesting. I could sit and listen to David talk about this all day long. As a matter of fact, if I could trap him in a conversation about soil health, I don't have to go work. I'm just teasing. So it's so enjoyable to hear you talk about it, and you're such a wealth of knowledge, and it's so helpful. So thank you so much. We all appreciate that. I know the customers appreciate it. I just want to remind everyone that if you have additional questions, or if you want to have other topics discussed during Founder Friday, or just us put out articles about specific things, or really anything that you're really interested in, please email us at info@azurestandard.com. You can put the topic Founder Friday question, or question for an article, whatever it is that you'd like to see us provide information on. We would love to hear that from you. More information on whatever it is. The team will make sure it gets to us, and that we're able to start addressing topics that you are interested in. We want to make sure that we are giving you all the information that you want and need to help you have successful gardens, live healthy lives, whatever the topic may be. I think you agree to that?
I'm not sure about whatever the topic, but only ones that have to do with food and farming and supply chain and logistics. We'll stick with those.
David likes to say I'm a little bit of a blanket everything person, so sometimes he has to rein me in a little bit. So we appreciate you greatly, and we thank you for being here today.
Thank you.